So, viruses. So let's start off, what even is a virus? Well, pretty much they're just infectious particles that can cause disease. They're made up of three important components. They have nucleic acids, a protein capsid, and sometimes they can have a membrane envelope. So nucleic acids are just the DNA or RNA that programs the virus to determine its characteristics. The protein capsid is going to serve as kind of a protective layer. I think you can look on your diagram, right? There's a protein capsid. And this is just going to, serve as like a shield, and it protects the genetic information, kind of how in our nucleus we're protecting our genetic information. And then the membrane envelope is just this like a circular membrane, like offers more protection really. So it's like a protein capsid, but it's even more than that. So there's just more protection really. And it's not in all viruses, it's just in particular ones. It's also covered in spikes. So I don't know if you've seen like COVID-19 like pictures of it or what it looks like, but there's these like little red spikes coming off of it, kind of like in the last picture. These ones. Yeah. Okay. So how do viruses work? Well, viruses kind of exist in this gray area where it's not really alive and it's not dead. It can't reproduce, so it does this instead. If you, again, look at the picture on to our right. So what it's going to do is it's going to take over a host cell. Now, a host cell is just going to be a cell that hosts the virus, right? So the virus is going to, I guess, interact with the spikes on the outside. And for the host cell, it's going to mistake these spikes that are on the outside and think that they're, I guess you could say, good spikes, and let the virus bind to the host cell. Once it does that, then the virus can insert its genetic information, and from there it can reprogram the metabolic or genetic machinery of the host cell to reproduce the virus instead of reproducing itself. So it kind of invades the cell and then tricks it into reproducing the virus instead of reproducing itself, which is kind of cool. Let's see. I do want to ask, can anybody name some viruses that you know of? Can anybody think of any? Maybe you've learned about some in class. Go ahead, Erin.
Coronavirus.
Exactly. Okay, perfect. Does anybody know any others? Samuel?
Measles.
Yep, that's actually one on my list. Perfect. There's also influenza, there's chicken pox, mumps. Yeah. Oh, Roshan, did you have one? Did I say it?
Oh yeah, you said it. I was about to say smallpox and chicken.
Yeah. Okay. So I think, that's what I want to say. Also, one thing to keep track of is that bacteria and viruses are different. So I think we've learned about bacteria, not the same thing as a virus. So let's kind of compare COVID. I mean, it's, probably the most realistic example you're going to be able to see, like, in real life, something you can experience and relate to. So COVID-19, it has spikes that it used to bind itself to the host cell's membrane. And then it also creates copies of itself. It, reproduces kind of like, or it doesn't reproduce, but it makes more copies of itself the same way most viruses do. What's different about it, though, is that when it's creating its viral copies, it actually uses something called the Golgi complex instead of the cell membrane. And then the Golgi complex rapidly spreads information. So it's kind of more useful, kind of makes it more dangerous. And then also there's a membrane that forms around the entire virus that protects the spikes from harm too. So usually you have a capsid which protects the genetic information, and the spikes are just on the outside, not really protected by anything. But in the case of COVID, they actually do have a protective layer. Okay, so let's move on to our activity. Can somebody read the objective for us? Go ahead, Samuel.
Objectives. Students will observe how different types of viruses interact with soap, a common infection prevention material.
Perfect. So now that we've learned a little bit about viruses, how do we protect ourselves? So, I mean, you guys probably know this, but can somebody name off some ideas on how we protect ourselves on a daily basis? Samuel?
Wash your hands.
Yep, perfect. How about Roshan, did you have something?
Be more specific with soap, because soap actually breaks the virus protein.
Yeah. Okay, and then Erin?
Taking a shower.
Yeah. So we're keeping good hygiene is what I'm hearing from here. Another thing is that when we don't really touch your face much, right? So I mean that's kind of the purpose of washing your hands. Once you wash your hands, then when you touch your face, whatever your hands have touched can't get into your body. But beyond that, also wear masks so we're not inhaling or exhaling any, I guess you could say, coronavirus particles or any virus particles that can be airborne. And then we also disinfect our countertops. We clean our kitchens. We keep our rooms tidy for the most part, right? So we're doing all this so we can protect ourselves. So now we're going to create a model of an enveloped virus, and we're going to also create one of a non-enveloped virus. So for the enveloped virus, we're going to be using coronavirus, and then for the non-enveloped one, we're going to be using polio virus. Okay, so everybody get out their materials. We're gonna need a sheet of aluminum foil, cracked black pepper, butter, a bowl, warm water, one paper towel, a spoon, double-sided tape, and 10 drops of liquid soap. So just bring whatever liquid soap you're using.
Can I close my video if I'm gonna go get everything?
Yeah, perfect. So when everybody has everything, give me a thumbs up, and then I'll know to move on.
Is it okay if I don't have the cracked black pepper?
It'll be less able to say. I mean, do you have something to substitute for black pepper?
We have red pepper.
Yeah, that works. So yeah, it's okay if you don't have the materials. You can still do it. It just won't be as easy to tell, but I think we'll still have enough to know.
Oh wait, I found black pepper. Sorry.
Okay,
Sounds
perfect. Okay, so another check. So give me a thumbs up if you're ready to move on. Oh, perfect. Okay, so let's move on to step 1. So we're going to roll 2 aluminum foil balls. So these are each going to be our separate viruses, and then make them about a 1/2 inch thick. And then, I mean, it's on the slide, but does anybody know what you think this inner core is going to represent in our virus? Does anybody want to say it? Go ahead, Roshan.
The DNA or RNA.
Exactly. So it's going to be the genetic material.
Does it have to be a proper ball or?
Just close enough. A shape.
Okay.
Got 1 thumbs up. Perfect. 2 thumbs up. Oh, 3 thumbs up. Perfect. So, step 2. So now we're going to cover each ball with double-sided tape, so that the entire outside is also sticky, but it's also sticking on. So double-sided tape. Does anybody want to take a guess, or it's also on the slide? What is this going to be? It's covering our genetic material, kind of like protecting it. What is it going to be? Go ahead, Roshan.
The protein capsid.
Exactly. So this is going to be our capsid protecting our genetic material.
Can we put it around both of them?
Yeah. Both of them are going to have a capsid. So 2 thumbs up.
Is it okay if I took one-sided tape and just made it double?
Yeah, as long as it's sticky both on the inside and on the outside, I don't really, it doesn't really matter.
Okay, so this is gonna take me a little more time to do that.
Yeah, don't worry about the time.
Okay. Okay, I'm done, by the way.
Awesome. So we're on step 3. So you're going to pour black pepper only on one of the balls until it's completely covered, and it should be completely black. Does anybody want to take a guess on what this represents? Go ahead, Roshan.
The spikes on the protein capsid.
Exactly. So right now we're doing the non-enveloped virus, so we haven't put anything else on it, right? We've just put a capsid and now we're adding spikes, so there's no envelope quite. Awesome. So let's move on to step number 4. So now we're going to do our enveloped virus. We're going to cover it in butter. And I won't ask what this is because, if it's our envelope virus, then this represents the envelope.
Should we melt the butter?
No, I think you can just like rub it on there. I don't think you have to melt it. So step number 5, we're going to roll. So we're gonna roll the buttered one. So our virus that's enveloped, our enveloped virus, in black pepper now. So that it kind of is gonna kind of look similar to the other one.
So we take the butter one and then put it in black pepper?
Yeah, exactly. So let's move on to step number 6. So now we're going to add 10 drops of dish soap into our bowl of water, and then we're going to mix it as best as we can. And then you can add the 2 virus models after the water and the dish soap is like thoroughly mixed. Go ahead, Roshan.
So should we put like the warm water in the bowl first?
Yeah, put the warm water in the bowl, then add the dish soap, mix it up as best as you can. Then you can add, when you're adding, let's stop halfway here. So when you're mixing your dish soap and your water and you're done mixing it, give me a thumbs up. And then together we'll put the virus models in there so that we can take 2 minutes, everybody together. Okay, so awesome. So I got 1 thumbs up. So when you're ready to put your virus models in, give me a thumbs up. Perfect. 3 thumbs up. Awesome. So now we can take 2 minutes, put your 2 virus models in. You can play around with them. Don't move them around too hard. Don't mess with the experiment too much, but you can swirl them around a little bit. Make sure that they're moving around. And then we're going to do this for 2 minutes. I'll set a 2-minute timer. And in 2 minutes, we'll reconvene.
What is the water supposed to be like mentioning? Like, is it supposed to be?
So the water is supposed to be us, I guess you could say, washing our hands. And the dish soap is the soap. So the soap and the water.
Oh, okay.
Yeah. Okay, so now we're going to move on to our step number 7. So let's take them out and put them on a paper towel. And let's make some observations here. What exactly is going on with our both? Do you see differences between them, or do they look the same?
Same.
They look the same? That's interesting. Go ahead, Roshan.
For me, it seems like the one without the envelope, it lost more pepper in the water than the one with the envelope.
Wow. Okay. Interesting. Any other observations before I move on? Okay, so of course this, experiment is subject to human error, but let's discuss a little bit. So, so what was supposed to happen is the enveloped proteins, because of the butter was supposed to kind of, I guess, not dissolve, but melt in the warm water. And because the spikes were on the butter, then that means that when the butter gets washed away, so does the pepper. And what was supposed to happen with the non-enveloped virus is that when it's in the water, because it's attached to the tape and not a butter, which can easily be, I guess you could say, like, kind of worn out. I guess, it's weird to say butter can be worn out, but butter can be worn out in water, whereas tape is harder to get worn out. So it didn't lose as much pepper. That's kind of what was supposed to happen. So, what this is kind of exemplifying is that on the enveloped viruses like COVID-19 are very heavily impacted when you wash your hands. Kind of like the butter, when you put it in water, it, completely goes away, and then its genetic material is exposed, and it's no longer a, heavily protected virus. Whereas non-enveloped viruses, they're kind of harder to get rid of because they're not attached to something so easy to get rid of like butter. They're attached to tape, so harder to get rid of. So pretty much wash your hands if you want to get rid of COVID. It's really important for enveloped viruses. So you guys have earned your 5-minute break. I encourage you to go get a snack, go to the bathroom, drink some water. So that happened to me while I was practicing this too. So let's move on. Can somebody read our objective for us? Go ahead, Roshan.
Objective. Students will use critical thinking to determine the source of a fictitious outbreak through a guided activity.
So we're actually going to be disease detectives today. But first, let's get to know a little bit about epidemiologists. So epidemiologists are just scientists who, track and analyze health factors, and I guess you could say controlled populations. So we can kind of, get to know what diseases, what's exactly threatening, human life at the moment, and what can we do to control it. So we're going to look at the source of the outbreak, how it spreads, and how exactly do we get this thing that's endangering us under control. So we're going to be disease detectives. So disease detectives just work with organizations like the CDC, so Centers for Disease Control. You guys probably have heard a lot about that ever since Corona. But they complete research on outbreaks, gather knowledge through investigations, and then they take all this information, again, analyze it, look through it, and kind of decide what exactly safety measures needs to be applied to the public, because you don't want to apply extreme ones, that exactly upsets people or kind of hinders, the regular human life, but you also don't want to under control and end up with a worse outbreak that kills people, right? So there has to be a balance. So does somebody want to read us our very top secret mission? Not really secret, but somebody want to read us our mission? Go ahead, Roshan.
Your mission. Hundreds of students at Hogwarts Academy have experienced trouble keeping their food down over the last couple of days. Many have been calling in sick or going to the nurse's office instead of going to class. Figure out what's going on.
Exactly. Does anybody know what Hogwarts is? Yes? How we watched Harry Potter? Roshan, do you want to go for it?
It's the place where Harry studies in the Harry Potter series.
Exactly. Perfect. So let's figure out what's going on with Harry Potter. I'll read the clues. So let's start off. After a fun school-wide dance, some students went out to eat at their favorite restaurant late at night. Some of the people in this group ended up going to the nurse's office on campus the next day, stating that they weren't feeling well and wanted to be sent home. Many more students started showing up the following day, and they were throwing up and using the bathroom often. As of now, the school nurse thinks that there might be a stomach bug that's being spread throughout the school population. So let's go into more information. The school nurses tell you that the students have gastroenteritis, an infection of the intestines and stomach, with symptoms including vomiting, headaches, and going to the bathroom frequently. The only issue is that their testing of the students doesn't identify this virus. So what exactly do we do now? Now, at the beginning, it's kind of difficult to decide what we are going to do, but as we move on, it will get a little bit easier with some practice. So number one, should we quarantine the students until they get better? Should we tell the students to avoid that restaurant and send them back to class? Or should we look for others that might be sick? Now, before you make your decision, and I want you to put it in chat, by the way, I want you to think about, we don't really know much yet, right? So how extreme of measures should we exactly take? So thinking of that, please put your answer in chat. You can either private chat me or send it to everybody, whichever one you like. Okay, I got 3 responses. So the correct answer is 3. You want to look for others that might be sick, because we can't really quarantine the students if we don't really know what exactly it is. That's pretty extreme measures. We go into virtual learning, and it's obviously better to learn in person, right? We also, telling the students to avoid that restaurant and send them back to class doesn't really solve anything. We can't really identify where exactly, it's going on. So we can't just say avoid that and, let's move on to, let's forget about the problem. So let's move on to clue number 2. So for clue number 2, since Monday, over 80 students have gone to the nurse's office and showed the same symptoms as the original students. For some students, the symptoms have been mild and have ended in a couple of days, but a handful of others have become extremely dehydrated. They were even sent to the El Camino Hospital for treatment. The stool feces of the students was tested for common bacteria that causes vomiting, dehydration, and frequent bathroom use, but they didn't test positive for any of the usual suspects. The samples were now sent to a nearby research lab to get tested for viruses. Pretty graphic. Oh, I gotta chat. Oh, did I lag? Can you guys hear me now? Okay, sorry about that. So let's move on to here. So you find out that the first students got sick on October 10th. The greatest number of newly infected students occurred on October 11th, and the last people who got sick started showing symptoms on October 13th. So what are we going to do now? Well, number one, we can find out from the students find out from the students what the students have in common that potentially made them sick. We could close down school and send all the students home for the week. We could instruct the students to not drink any water or eat anything for the next day. So, which one do you guys think it is? Put your answer in chat. I got one answer. Oh, I got 3 answers, and you all agreed on number 1. So, I do want to say that is the correct answer. We can't close down school and just send them home for a week, again, avoiding the problem. And then, instructing people to not drink or eat anything also does not solve the problem. Not only that, but how are you going to enforce that, right? So we have to find out, what's in common. They didn't all get the exact same disease from, 15 different sources, or how many kids was it? 80 different sources. There's probably something they all have in common. So let's look for those similarities. So clue number 3. No more people are getting sick, and even those in the hospital have started to have milder symptoms and are even feeling a bit better. After interviewing students, you found some similarities between the results. All of them live in the same neighborhood. Everyone used the school water fountains. Everyone ate hot lunch at school at least a few times a week and during the contamination period, October 11th through the 13th. And most of the students are not in class together. So, let's move on. So where did the outbreak start? We have the water fountains in the dorms, we have the classrooms, and the hot lunch pickup room. So let's see. Oh, I thought it was for a second. Okay. So if you go here again, everyone uses the same water fountains, everyone lives in the same neighborhood, everyone ate hot lunch, and most of the students are not in class together. So was it water fountains? Was it classrooms? Was it the hot lunch room? What was it? Put your answer in the chat. Okay, I think I got two answers, so I need one more. Okay, so again, I think everybody agreed on 1. However, the correct answer is 3. So let me explain this really quick. All the people affected had eaten hot lunch during that time period and might have been to expose the virus covered by food, right? Or the virus covered food. So the food covered by virus. Other students brought lunch from home or ate off campus, so it's rather, strange that only the students who ate school lunch got sick. So I think what's really trying to say here is that because it's like an intestine disease, right? It's more likely that we got it from hot lunch than it is the classrooms or the water fountains. I mean, the classrooms, people didn't even have the same classrooms, right? So it's very hard to pinpoint exactly. But let's read clue number 4. So you begin interviewing other students who have not had symptoms to make sure that the hot lunch was really the start of the outbreak. I got a chat. Use the water fountain. Everyone did use the water fountain, yeah. So I think what's important to remember is that it's more like an intestine disease. So we're looking more for food. And then also everyone using the same water fountains, they all had different lunches. So, but as we go on, it'll make more sense. So you begin interviewing other students who have not had symptoms to make sure that the hot lunch was really the start of the outbreak. After speaking with 350 more students, you find out that most of them did not eat any food from the hot lunchroom and only ate and drank products from home, while about the 50 did eat something from their friends' hot lunches and did not get sick. Now it's time to find the exact food the exposure might be coming from. So let's go into more information. Most of the students ate pizza, while the students who didn't experience symptoms ate vegetables and cookies from their friends' lunches. You talk with the person making the pizza at school, and she tells you that she had been vomiting and having stomach pain a few days before the large outbreak. You also notice that she doesn't often wash her hands and touches the money students hand her, the counters, and the food. Only 30% of students who had veggie pizza got sick, while over 50% of the students who had pepperoni pizza did. So, what's making the students sick? The vegetables, the pepperoni, or multiple pizza toppings? Put your answer in chat. Okay, got one answer. Samuel, did you mean to send W or something else?
I meant to send 2.
Oh, okay. Okay, so everybody said pepperoni. Now, see, that's a very good guess, and a lot of people get a little bit confused on this part. So, it says only 30% of the students who had veggie pizza got sick, while over 50% of the students who had pepperoni pizza did, right? So I think what we're thinking here is, well, if more people got infected from the pepperoni pizza, then it has to be the pepperoni. But the correct answer here is multiple pizza toppings. So, you know, even if only 30% of the people who had veggie got sick, people who had veggie still got sick. So it can't just be one or the other. It has to be both, right? Unless the veggie got contaminated with something else. But you guys were half right. So let's move on to clue number 5. So you got the results from the research lab, and the feces samples from the students show that they all tested for a virus called norovirus. The evidence strongly suggests that the pizza chef had similar symptoms and had not thoroughly washed her hands before dealing with the food given to the students. So what can we do to prevent outbreaks like this in the future? Now, these are all very good answers, so you know there's not really a choice here. But what we should say is we should have a talk with the pizza chef and tell her to not prepare food when she's sick. Make sure that all the chefs make sure that all of the chefs was their hands well before handling food. That was not written very correctly, but I think you guys know what it's trying to say. And then force all staff to take tests every week to make sure they don't have norovirus. So. And all of these are pretty good. The only one I would say that's kind of extreme would be number 3. I don't know if you can enforce mandatory testing. Yeah. 2 is a good answer. Yeah, I agree. So in general, you know, what's important is number 1 and number 2, I think, you know, is more, you know, most important to kind of emphasize. You have to make sure that you're not, you know, preparing things or going to school or going to work or going wherever when you're sick. You don't want to cause a more outspread infection than there needs to be. And then you also want to wash your hands. I mean, that's very, you know, really simple. It takes, you know, 1 minute, and you just, you know, kind of like we showed the experience, or at least we try to show, it washes away all the spikes and everything.